As a substance specially used to treat ozone in exhaust gas, ozone destruction catalyst plays a vital role in environmental protection. It can efficiently decompose ozone into oxygen at room temperature without additional energy input. Its working principle is mainly to promote the ozone decomposition reaction by relying on the active sites on the catalyst surface. Usually, ozone destruction catalysts are composed of metals or metal oxides such as iron, copper, and manganese. These materials have unique electronic structures and chemical properties, so they have high catalytic activity and stability, even at lower temperatures. They can effectively promote the smooth progress of ozone decomposition reactions. When ozone comes into contact with the catalyst, it triggers a series of complex chemical reactions on the catalyst surface. First, ozone molecules are adsorbed onto the active sites of the catalyst. These active sites can create a specific chemical environment, making the chemical bonds of ozone molecules unstable. In this case, ozone molecules are prone to decomposition reactions, thereby forming oxygen molecules and active oxygen species. Among them, the active oxygen species are further converted into hydroxyl radical O under the action of the catalyst. Hydroxyl radical are extremely powerful oxidants that react very quickly with organic matter and have stronger oxidizing properties. Almost all organic matter can be oxidized by hydroxyl radical. Under the action of ozone destruction catalysts, organic matter in water can be directly oxidized into carbon dioxide and water. For macromolecular organic matter, the catalyst can convert it into small molecular organic matter, making it easier to degrade. This catalytic process is efficient and selective. The catalyst can promote the ozone decomposition reaction in a targeted manner without causing too much adverse effects on other substances. At the same time, due to the presence of the catalyst, the speed of the ozone decomposition reaction is greatly accelerated, so that the ozone in the exhaust gas can be decomposed into harmless oxygen in a shorter time. The ozone destruction catalyst produced by Minstrong is even more outstanding. It can efficiently decompose ozone into oxygen and eliminate ozone odor, thereby meeting the exhaust gas emission standards. The product uses chemical synthesis to manufacture active components and accurately controls the various process parameters of the synthesis reaction. Using alumina as a binder, the active ingredient content of the ozone destruction particles and particle catalysts produced by Minstrong is greater than 85%. The ozone destruction catalyst powder does not contain a binder, and the active ingredient is as high as 99%. This ozone catalyst product does not contain activated carbon. It is resistant to high temperatures when dealing with high concentration ozone. It is non-combustible and non-volatile. It is safe to use and does not cause secondary pollution. Therefore, it is very popular among customers in the field of ozone removal.